Good day, everybody, and welcome to our monthly Green Talk series. Today, we have Professor Samson Alayande speaking to us about the role of sustainable and green chemistry in a circular economy. Professor Samson Alayande is currently a research professor at the University of Minnesota. If you have any questions, please email them to greentalk@greenyourlab.org. Green Your Lab is a global movement of sustainable scientists and green lab enthusiasts working to make research and lab work more sustainable. If you'd like to learn more, you can go on to greenyourlab.org and join our network to get your questions answered, join talks and seminars, network with others in the space, and get information or add your best Green Lab tips to our Green Lab Best Practices database. For these talks, we have teamed up with NESSE, Network of Early Career Sustainable Scientists and Engineers. NESSE is a global movement of researchers and young professionals who are working on finding solutions to today's most pressing sustainability challenges. We would like to thank and welcome everybody for being here. If you have any questions, please don't hesitate to email them to greentalk@greenyourlab.org. So without further ado, I present to you Professor Samson Alayande.
Okay. Yeah, it's a pleasure to have you, wonderful people in NESSE, and it's also wonderful to have Adi Diana that has worked with me to ensure that this presentation is it's a success. I also would like to appreciate all those who are members of NESSE and all those who have joined us online for this wonderful talk at this hour. It's like having been said, my name is Samson Alayande. So if you have any question in the course, you can use the chat medium to communicate your question, and thereafter, I will attend to all the questions. So today we are looking at the role of sustainable and green chemistry in circular economy. So basically, the concept of sustainable and green chemistry, it's a scientific concept which mainly seeks efficiency of natural resources in order to meet human need, and of course, not at the detriment of human or the environment. So we are looking at efficiency use of resources, both in terms of chemical resources and in terms of natural resources. It also encompasses design, manufacture, and efficiency and safe, but most importantly, we are looking at environmental benign chemical products and processes. We are looking at toxic free products. We are looking at products with long-term impact and very low toxic impact. We are also looking at efficiency in the lifespan of the product. We are looking at products uh, that can stand the test of time while also retaining their integrity. Now, again, it's also been classified as design of chemical product and processes that reduce or eliminate use and generation of hazardous material. So we are looking at complete elimination of hazardous material from the raw material even to the life cycle of the product during the processing, and even after the processing, during usage and after disposal. We are looking at products that do not generate hazardous substances. So this has led to development of 12 principles, which are called the principles of green chemistry, in which we looked at pollution prevention, atom economy. We looked at less hazardous chemical substances, design safe chemicals, safer solvent and auxiliaries, design for energy efficiency. We are looking at use of renewable feedstock, reduce derivative catalysis. Of course, with catalysis, you are looking at making the reaction faster and reduction in activity energy. We are looking at design for degradation. We don't want something that will impact the environment, that will resist degradation, impact the environment negatively. We are looking at lifetime analysis for pollution and we're also looking at inherently safer chemistry for accident prevention. So these forms the 12 principle of green chemistry, which has widely been embraced globally. So globally, there are a lot of organizations that are promoting green and sustainable chemistry. And before now, most of these organizations presented here are organizations at the forefront of promotion of green and sustainable chemistry. So before now, most organizations in Europe, they were pioneering and promoting sustainable chemistry, particularly International Sustainable Chemistry Collaborative Center. And while most organizations in the United States were promoting green chemistry, but in the last few years, this effort has been harmonized. So that's why we now have sustainable and green chemistry, knowing fully well both concepts drives towards the same objective. So well, I'm happy that Beyond Benign is also playing a leading role in terms of promotion of green chemistry education, and they coordinate green chemistry commitment in which most universities are encouraged to participate. And I'm happy that I introduced this concept into undergraduate curriculum in Africa, and my university became the first institution in Africa to introduce green chemistry into its undergraduate curriculum. Yeah, International Sustainable Chemistry Collaborative Center in Germany, they also do a lot in promoting green and sustainable chemistry, in which I've also worked with them. NESSE, or Network of Early Career Sustainable Scientists and Engineer, they do a lot to promote green chemistry. IUPAC organize a lot of summer schools on green chemistry, and they also give grants to young researchers. Green Your Lab is an online network also promoting sustainability. American Chemical Society, Royal Society of Chemistry, My Green Lab, and of course UNIDO. Well, they develop the material, the curriculum on green and sustainable chemistry. So all these organizations, they are geared towards promoting global awareness and synergy. And of course, there are so many other organizations, institutions. Of course, these are major institutions outside the wall of the university that are promoting green and sustainable chemistry. So back to how does we understand the concept of circular economy? Well, the concept of circular economy, I would say, is majorly was have been promoted a lot by uh, a group, a foundation, Ellen MacArthur Foundation. They have promote this concept of circular economy so well, and I'm glad that they have provided a lot of useful resources. Well, it's basically a framework whereby so many of the global challenges are being addressed, so that such as waste, such as pollution, such as climate change, biodiversity, and other ecological challenges are being addressed. So, in a circular economy, we are looking at an economy that activity is not based on consumption of finite resources. We are also looking at an economy that is not a linear economy, that is from raw material to product back to waste. Now that's a linear cycle, but you are looking at a cycle in which that evolve itself, allowing many innovation, reuse of some material. You are looking at an economy that has a positive impact on the environment, not an economy that depletes the environment without looking at the consequence. So basically, there are three principles in circular economy: to eliminate waste and pollution, to circulate products and materials at the highest level, and to regenerate value. That is, you are basically looking at economy that this transition will be from non-renewable energy to a renewable energy. You are looking at the economy that majorly all raw materials will be sourced from renewable feedstock, and if it has to be from finite feedstock, it will have a long product life with high value to both woman and its environment. So if you compare the circular economy and the linear economy. So in the linear economy, you have what it's just simply you take from the feedstock, whether finance, you don't even care, or whether renewable. Now you make it into your product, and after it's single use, you just discard it. That's a linear economy. But in a circular economy, you are looking at okay, you take from a renewable feedstock after a single use, you process it again into another usage. So even at disposal, it's being processed into. So in a circular economy, there are so many transformations for every product that comes out that is being used, rather than go back into the landfill, rather than go back to the ocean, rather than go to the incinerator. It can be reused, it can be recycled, it can be reprocessed into another viable either that same product or being a precursor for another chain of production, another production chain. So that gives two basic concepts that material in linear economy of course they are being wasted after every single use. So it's like just like from usage to the dump site. Now that's a single economy. But in a circular economy, you have the 3R principle applying after usage. You can rethink, you can reuse, you can reduce, and you can recycle, and that gives a circular economy that max optimum use of materials and a long product life for the material. Also, in a circular economy, your raw materials is being sourced, raw materials and energy is you prioritize renewable feedstock, you prioritize renewability. You do not want to deplete. You do not just want to use and from a finance source. But in a linear economy, raw material energy are majorly from finance source. Of course, you know that globally now the energy demand is increasing, and of course the global investment on renewable energy is also increasing because everybody has come to term that we cannot continue to look at non-renewable sources for energy because of the negative impacts on the on negative impact on our planet. So circular economy drives energy demand. It's drive energy generation from a renewable source, and of course you are also looking at sourcing your raw material from renewable feedstock. So in the cycle known as circular economy, there are two basic pathways as described by the MacArthur Foundation. So there are two basic pathways. One, the first pathway is the technical pathway. Now, in the technical pathway, of course, we cannot shy away from the fact that we still have to depend on gold from Congo, and diamond from many from the hard cross. We still have to demand on steel from the hard cross. We still have to demand on petrol. We still have to depend on petroleum. But however, now once we during after explore or the process of mineral exploration, now rather than just use a single use and being done, so the circular economy provides several pathways to keep the product life more prolonged than what we have linearly in the linear economy, what we have ordinarily in the linear economy. So when you generate when you after the mineral exploration and a product is being produced, now when the product is being produced after the first cycle, that same product can be recycled. Now, of course, when it is recycled, of course, that can lead to either you refurbish. If it's an engine, you can refurbish it. Then, of course, if it can be refurbished it and of course be reused. Again, it can also be melted down and remanufactured, recasted another form of engine, and it goes back into circulation. It goes back into usage. Again, another form is the concept of reduce or redistribution, in such a way that, okay, cars that have been used for some years can be redistributed to maybe developing countries and other regions where the need for that particular value is still very relevant. So that is the concept of, so rather than it becoming a waste. And if you look at this is very prominent in the area of every machineries, in the area of vehicles, in the area of electronics, whereby some of the used, or some of the heavy machines that have been manufactured in 10 years, and whereby where the develop in the developed country, they have actually upgraded, so, and being returned to the manufacturer. So the manufacturer rebought them, and it is being sold to developing countries where the need and some of the values are very relevant to the environment. So it keeps the product life being prolonged than ordinary. Again, you can also maintain in such a way that rather than discard your phone when it's not, maybe the earpiece is not doing well, so it can be maintained, it can be repaired, and of course, once it's been repaired and just is being discarded, of course, you keep using it. Then you can also do the concept of sharing. In sharing, well, I have a device, and my I use it periodically, so I can create a window whereby any other person that wants to use the device can use it, and that happens a lot to prolong the product life of any product. So, and all these, for every of this cycle, the end it boils down to the end user, whereby the end user derive optimum value from it. So in this, it keeps this so this activity keeps the product life cycle being prolonged than just mere usage once, and let's say, oh, I need another one, and that's how you settle for another. So that is the part for technical. So if the other part is the biological part, whereby you are seeking feedstock, you are seeking your raw material from renewable feedstock. You are looking at bioconservation. You are looking at non-depletion of bioresources. And primarily, you are looking at, okay, well, can I do my extraction from biological feedstock now? And once you can do that, then you can do a lot of structural elucidation, which you understand that then you can do a scale up of that. So with that, you can go back for your regeneration, and with that, of course, you can also encourage conservation through deliberate agricultural activity to sustain your bioresources. So in summary, this is just being summarized in three principles that, one, you are from the initial concept, you are looking at designing to ensure that from your design, you phase out or you minimize waste and pollution. Again, you are also looking at from the onset, you want to keep the product and the material in use for a very long period of time. So you are so from right from the time right from so your design from onset is just, I'm not just looking at the product just staying with the owner, well, just staying with the first user. I'm looking at a product that can last beyond the immediate user. Again, you are also looking at regenerating natural systems. From particularly, you are looking at generating that regeneration from a renewable feedstocks. So, how do these two principles, major principles, align? The principles of green chemistry and green and sustainable chemistry, and the principle of sustainability. Now, if we look at uh, so if we begin to look at the principles of green and sustainable chemistry one after the other, Like the first principle, that's the principle of prevention. Now, naturally, that it aligns with keeping your product and material in use. It also basically aligns with the principle of designing out waste and pollution. So if you look at the principle of atom economy, you want to get the best value out of every of your system. You want to get a very high value out of. So that also aligns with two principles in the circular economy. You are also looking at less hazardous chemical synthesis. You are looking at a synthesis procedure that has minimal or no negative impact to human and the environment. So, of course, that aligns with keeping the product and the material in use, because you are also looking at designing out waste and pollution. Let me state this, that one of the worries about sustainable about circular economy is that people have expressed concern that the unintentional retention of toxic substance can be encouraged with circular economy. But the green and sustainable chemistry answers that question, because right from the design, you are looking at ensuring that you do not have a toxic substance, either by during the reactant phase, or the product, or the byproduct that may be formed, or the derivative of some of the product interaction with the environment. So that answers some of the worries as regards circular economy. So basically, that and the designing of safer chemicals aligns with all the principles, the three principles. Also, with safer solvent and auxiliaries that are being used in the course of the chemical reactions and processes, aligns with all the three principles. Design for energy efficiency, we are looking at a process that will not be high energy driven, but we optimize the use of energy. Also, the use of renewable feedstock and reduce derivative. We are not looking at a product that will have so many byproducts which you cannot even control. Catalysis, of course, catalysis it has helped a lot to reduce reaction time and other factors. And this also is in tandem with the three principles of circular economy, and these are has been established. This has definitely aligns with all the three principles of circular economy, and also inherently safer chemistry for accident prevention. Circular economy and green and sustainable chemistry believes that we should ensure that we eliminate hazard. We should ensure that we eliminate accident as a result of production, as a result of activities of chemical processes. So this aligns with the three principles in circular economy. Is also in tandem with the principle of green chemistry. Now, the concept of life cycle analysis now became a very prominent issue within the design of chemicals, within the conceptualization stage. Gone are the days that you just wake up and you jump into your idea without necessarily looking at what would be the impact before it's being commercialized. Now, this gives understanding of trying to understand from my raw material to my product development, what is the impact that is likely to be generated. That is my raw material sourcing. Where do I source? Are they from finite? Are they from renewable stock? Then again, we also begin to understand during the manufacturing processes what are the likely impacts to the likely either processing or raw material or byproducts that may be be generated during that phases, and what are the likely impacts that may be obtainable. You are also looking at understanding the usage. Now, during use of my developed product, now what are the impacts? Okay, on reaction with on exposure to sunlight, to or what are there going to be a react? Are there going to be byproduct, by reaction, degradation? Is it stable? So you are looking at that again, and that is classified as from cradle to usage. Or you are also looking beyond that okay, from the cradle to the grave. Now, at the end of the first usage, and in which maybe the first user had to carefully dispose it. What's again is the impact at that level. So, and at every impact, you are also looking at what's going to be the not only to the user, you are looking at the impacts to the environment. You are looking at the impact to the ecosystem. You are looking at the impact even beyond the usage to the user. What's the impact to the health of the user? What's the impact to the immediate environment? You are also looking at the effect during disposal. What's the impact? How long can it stay? And how again? Then again, you are looking at cradle to cradle. Oh, how do I recycle it? How do I reuse it? How do I reduce undesirable that may arise from this? And how do I maybe upcycling again? Is it possible for me to upcycle? And again, you are looking at this. Okay, if I recycle, what's the impact to the entire ecosystem? If I reduce, what's the impact to the entire ecosystem? And if I so for every stage, the product is subjected to a life cycle analysis, and so many understanding that inform reinvention, that inform many life cycle inventory, and proper understanding of the material is now being promoted. And this is a cardinal concept in the design of safe chemicals in green and sustainable. And with these, many of the three principles of circular economy will be carefully engineered to ensure that the products do not have negative impact, and the product stays beyond the first user. So some principles have been developed to align and identify with application of green and sustainable chemistry in circular economy. Now, one of it is, there are eight of it, and one of it is new pathway, and this talks predominantly about non-reliance on non-renewable fossil fuel feedstock and other non-renewable feedstock, to exploration of biodiversity and natural capital. Again, secondly, you're also looking at safety. Safety is being prioritized as application of green chemistry in the circular economy. So, with safety, you are looking at minimal or no or no. You are looking at zero tolerance for chemical hazard. You are looking at zero tolerance for chemical toxicity, and that promotes maintenance, prolonged use of the product, reuse and redistribution. While the new pathway, that promotes sharing of the product that may be obtainable. You are also looking at one very great application of green chemistry in circular economy is you are also looking at predominantly at durability. You are looking at a material that will be durable, not and still retain its integrity after the first usage. You are also looking at retention of integrity, and this. So with this, you can refurbish. With this, you can subject to remanufacturing. Of course, you are looking at reversibility in such a way that you can, from the polymer, you can recycle back to monomer, and you are looking at that kind of reversible reaction. You are looking at a product that can be subjected to repair, that can be repaired. So the concept of reversibility and concept ability to repair, it promotes recycling, and with that you can easily recycle again and again for prolonging the product life beyond the single first user. Now, green chemistry also encourages purity, and beyond purity, it also encourages ease of separation of when you are using a composite material, so that with that it to be easy to regenerate and to be easy to reuse. Basically, all these principles are being summarized by the green chemistry blueprint blueprint for green chemistry opportunity in circular economy. So you can check the material for further information. Well, I'd like to thank everybody who has been online. I'd like to appreciate everybody for your time. Thank you.
Thank you so much, Samson. That was an awesome talk. We did get a few questions from the audience. If you have any time to answer those.
Okay.
One question that I just had was, you're working at the Center for Biopolymers, and I was wondering how you saw biopolymers fitting into the circular economy. I know that traditional polymers are kind of in the technosphere of the circular economy where they need to get recycled. I didn't know if biopolymers are being designed for degradation or if they're kind of being designed for also recyclability.
Yeah, polymers are actually being designed in such a way that you can easily compose after use it. And but basically, you should understand now that biopolymer has been subjected to reuse. To reuse. As I speak now at the U of M, we are working on reusing PLA cup for oil spill after the first single use. So you are not looking at taking it back to composting after the first single use. You are looking at converting it to another product, and thereafter subjecting it to another usage. So we are looking at keeping beyond first usage. So the global move now is to discourage single-use polymer, to discourage single use of any polymeric product.
That's really cool, focusing on the durability of the product, and then not a different kind of circular economy where it's a different kind of single use, but really improving the lifespan of all the products.
Yeah.
That's awesome. And I was just curious what you thought the biggest barriers to the circular economy are right now. Is it like from a technical standpoint or like an adaptation or policy standpoint?
Yeah, well, I'm currently working on a book called Circular Economy Mirage in Developing Country. I'm working on that book now. I hope I'll be able to intensify more effort to complete the book in not distant future. Now, because as we speak now, from the policy perspective, for circular economy to be implemented in developing countries, there are still going to be a lot of infrastructure. There are a lot of infrastructure deficits in developing countries. So the concept of upcycling, recycling, reusing is not there. So for most developing country, it's the what is still obtainable. It's basically a linear economy. So, but in the developed country, yes, circular economy is already playing its role. But however, there are still a lot of challenge with adaptation. There are still a lot of challenges with the policies are there. The policies are coming up with global awareness, and more importantly, the global leaders are everybody is awakening to reality of climate change, and that is calling everybody that all hands must be on deck. We saw what happened in the UK with the global warming. I mean, everybody has to go back and see that we have to do something now. We cannot fold our hand. We saw what's happening. We saw hurricane. We saw fire everywhere now. So everybody knows. So, but we can't eat our cake at the same time have it. We still want to keep the global economy moving. So there must be deliberate reduction of dependency on fossil fuel. And that, of course, we also, if it's too spontaneous, poverty will be promoted in a lot of nations that depend majorly on fossil fuel. I mean, the Mid East, a lot of countries in Africa will jump straight into poverty. So it's a issue of policy, it's an issue of adaptation, and it's an issue of also commitment from major stakeholders, because the concept there is, if I have to develop my polyteraphthalate bottle, and if you insist that, oh, I must focus on, develop on a product that has integrity, then it also boils down to cost. So there are so many factors that has to come into it, but it's something that all of us, if we are all committed to it, we all live to enjoy it.
Yeah, that's really well said, and I'm really excited to read your book when it comes out. I don't know if you can speak a little bit more about, like, you touched upon it definitely, of like the differences between like research in the United States versus research in Africa, but it sounds like there's kind of a whole different aspect to like bringing the circular economy to like Africa
Yes.
and developing nations.
Yeah, I can speak on that because my background, everything is actually in developing countries. I've worked in many labs in developing country, and I'm proud to say I've worked in the leading economy in developing country. I've worked in Nigeria, I've worked in South Africa, I've been to Kenya, I've been to Tanzania, I've been to over 10 countries, in 10 to 15 countries in Africa. So I know what is obtainable over in Africa. Well, for in terms of research in United States is specifically targeted towards development. So there is a deliberate, and there is a commitment right from the government to the grassroots on to target certain area of national interest. That's so area of national interest is being identified, and there are commitment to that. There are funds, there are support, there are so many encouragement in that regard. Going back to Africa, well, Africa believes, yes, Africa knows that, oh, science, technology, innovations are important, but there is no commitment. There is no, and where there are commitment, if you see what is happening in South Africa now, South Africa is reducing its vote on research, science, technology, and innovation year by year. So they are also coming down in terms of research output. But there is no commitment in Africa. There's no priority research. There's no national interest in Africa. So what most researcher does is what interests you as a person. So if I'm interested in green chemistry, I am driving green chemistry. Everything I have done to green chemistry is not from my government. I have never gotten a support from my government on green chemistry. No, I have never gotten a support from my government on green chemistry. And I was very proud that my former vice chancellor and even my current vice chancellor, they gave moral support. But I can tell you that it's just one out of every million giving that kind of even moral support to you for you on. So it's driven by the passion of the researcher. So if the researcher is passionate, of course, he can fly high. But if he's not passionate, and again, the other angle that is also sustaining research is the international community. Well, I participated in the Global Chemical Outlook too, not based on recommendation of my government, but based on funding from IC3 and UNEP. That was what took me to Global Chemical Outlook 2, in which I was part of the African experts that reviewed and modified the document. So the international community, but of course the international community will support you also in tandem with their interests. There are so many problems in Africa that is not of international interest. So who supports that? So it's but when the commitment, and that's why what we have in Africa is the cost of governance is more than the cost of in any sector that is relevant to the well-being of the people. So I mean, the cost of governance is the extremely and the priority of any African government. So with that, that has impeded development, and that's why I'm in my book that I'm currently working on. I call it a mirage. I call circular economy drive a mirage in Africa currently. So except there is a paradigm shift, except there is a rethink, except there is a deliberate commitment. And I must tell you sincerely, I don't see that happening too soon, but I see that happening in not a distant future. So that is my take.
Yeah, so I didn't realize how much like people like you who want to study these subjects don't really have the resources in your home country and really rely on the international support for it. And that's it's I mean I think that you're right that like it might not change um, too quickly, but I do think that people like you who are able to inspire other people like you are definitely making that push. So it's definitely a good analysis that it is a bit of a mirage right now. Like it's something you kind of want to see, but you can't fully reach at the moment.
Abe, I must also tell you this sincerely, and that's it's from the depth of my heart, is that you have good ideas. All the best, all the best brain in developing country are living developing countries.
Yeah.
All the best brains, all the best brains. Every day, I keep my colleagues are relocating every day. Why? There's insecurity. So if you are innovative and you are in the midst of insecurity, you will run for your dear life. The future is uncertain, and the most frustrating there is that the future of many innovative scholar is just being toyed with like a matchstick. I will tell you that just recently now, the academic staff in Nigeria were on strike for over 9 months and not being paid. How do you retain your best brain? How do you retain your best mind? I mean, you are a scholar, you are not being paid for 9 months. It's frustrating. If your
Yeah.
children fall sick, if your wife falls sick, if you are sick, you just be wasted.
Yeah.
And during that period, many lives were lost. Many brains were lost because they could not keep up with their lifestyle, because they could not maintain their lifestyle. So that it's a big, it's another big. So, but to me, wherever you find yourself, and I mean, I speak to the audience. If you are innovative, wherever you find yourself, please keep the flag flying wherever you find yourself. In any space where you find yourself, retain your passion, d- keep driving what that which you believe in. It might take you a while for you to settle down, but of course, it's just a matter of time.
Yeah, that's very inspiring. It does sound like the best kind of way to support the circular economy in developing countries is to give them the means to live where they are, and because they know the problems best and they can
Yeah.
solve it the best. It's just giving them the resources to be able to work and live there to like fill out their potential. So this has been really amazing talking with you, Samson. It was a great presentation. It was great talking with you. I think we have a few more questions, but maybe we'll only take one more just because we're running up against 1 o'clock. Um, so I think this question is about life cycle analysis. How do we stop? Um, Sometimes it seems like people can kind of manipulate the system to get better numbers on life cycle analysis, and that kind of seems to drive a lot of change. So I didn't know your perspective on life cycle analysis and the perception of the circular economy. If you like it as a tool, like if you have any critiques.
Yeah, my critique is it's important that an independent psychoanalyst evolve in such a way that if you are the researcher and you are the one subjecting your innovation to psychoanalysis, you might not be truthful and sincere enough. So for your product to stand integrity and to be attest to, it is important that we have an independent life cycle analyst in such a way that who is different, who is outside the group of the researcher, of the innovators. So with that, you have a sincere life cycle analysis. With that, you have truthfulness, a reflection of what may happen from the grave even to the cradles and all through the life cycle of the product. But I mean, you might be so passionate and so overwhelmed with your invention, your innovation, that you forcefully want to see it move, transit from the lab to the product. So with that, you might miss out a lot of sincere criticism of yourself, of what you have developed. So that's why I honestly recommend that many of us, a new field must emerge in grants sustainable chemistry, which is known as the life cycle analyst, and they will be subject and trusted with that in such a way that they have a wide understanding and they have a versatile experience, and in such a way that they can be able to analyze and see the product through the tin hole from the lab to the product stage and to the dump site, to recycling, to the upcycling, back into reuse and other derivative.
Yeah, that's a great idea. Yeah, using the life cycle analysts. Awesome. Um, yeah, I think that's all the time we have, but it was amazing talking with you, Samson.
Yeah, it's also amazing talking to you too.
So thank you so much. Hopefully we'll see you at other NESSE talks, and I'll end it here. So thank you again.
Thank you again. Thank you for the opportunity. Thank you.
Yeah. Bye.
Bye.